Hi everyone, I'm Benen and I'm presenting my EM3 on the Euler method. The Euler method is a numerical procedure used to approximate solutions for initial value problems. Before we solve our specific equation, let's look at how the general formula is derived. Let's look at my graph here, and this is the solution curve. And we have starting points y0 and x0. Our goal is to estimate the next y value y1 after moving forward along the x-axis by a constant step size, also known as h. Since we do not know the exact curves equation, Euler's method assumes the curve moves like a straight line over the tiny step. So we draw it from x0 and shoot it over to y1 x1. Now let's look at the algebraic derivation steps. The slope of our straight approximation line, which we call the m, or the gradient, is calculated along the basic formula rise over run. So that's y1 minus y0 over x1 minus x0. And we also know that from calculus, we know that the actual derivative dy over dx represents the slope of the curve at any point, defined as a function fxy. So at our starting point, the slope is exactly fx0, y0. So we put it equal to the gradient, and x1 minus x0 is just h. So we get this, and then now we just simplify it, and we do the cross method, and we move y0 over to here, and this is the general formula. Now let's move over to the Excel sheet. Now let's look at how to do this in the Excel for a specific problem. Our equation is fxy equals to x squared plus 2 over y. Our starting y0 equals to 1, and we want to find the value of y when x equals to 1. As you can see on my spreadsheet, I have 4 columns, n, x, n, y, n, and our slope function f, x, n, y, n, and our step size is h equals to 0.2. We start at step 0 with our initial values, x equals to 0, y equals to 1. In the last column, I type in our slope formula using Excel cells, and it takes our current x squared plus 2 and divided it by our current y, and it gives us 2 for the first row. To find the next x, we take the old x plus the step size, which is 0.2, and we get 0.2 for this one, because 0 plus 0.2 equals 0.2. And to find the y, the new y value, we use the Euler formula, and we take the old y and add it to our step size h multiplied by the old slope. And for the example, this one is 1 plus 0.2 times 2, which gives us 1.4. Once those formulas are set up, we drag them all the way down to 5 rows, and when x equals to 1, y is equals to 2.43045. Now let's look at how close the exact calculus work is to our Excel table. We can solve everything using the separation of variables. This is our equation, dy over dx equals to x squared plus 2 over y, and we integrate this and we get this equation where c is a constant. Now the initial value, we plug in the initial value of y0 equals to 1, and we get c equals to half. And we plug c back into the equation, and we multiply everything by 2 to get y squared equals to this, and y equals to plus minus 2 over 3 x to the power of 3 plus 4x plus 1. And we plug in, we want to find y when x equals to 1, so we plug in x equals to 1, and we get 2.3805 or negative 2.3805, but we reject this because y is bigger than 1. Now to find the error is actual minus approximate. Our actual is 2.3805, and our approximate is estimated to be 2.4305, and we get negative 0.05. The negative sign just means that our Excel guess is slightly higher than the real answer. This overstep happens because the Euler method assumes the slope stays completely flat across each step interval. But since the true slope of our curve is actually increasing, the tangent line step shoots slightly over the real curve. Thank you so much for listening to my presentation.